All right, let's talk about something fundamental in automation, getting your machines to actually talk to each other. It's a huge deal. Today, we're going to pull back the curtain on one of the most powerful tools in the toolbox for doing just that, the S7 Get instruction. Let's get right into it.
So, picture this. You've got two PLCs humming away on your network. One of them is reading a critical temperature, or maybe it's keeping track of the production count. The other PLC needs that data, and it needs it now. So how do you bridge that gap? How do you get that piece of information from point A to point B reliably whenever you ask for it? Well, that's exactly the problem the Get instruction was built to solve.
So here's how we're going to break it all down. First, we'll nail down what the Get instruction actually is. Then, we'll cover the prep work you got to do beforehand. After that, we're diving deep into the parameters, the nuts and bolts of it. We'll walk through a real-world example to see it in action. And finally, we'll cover how to know if it worked and what to do if it, well, doesn't.
All right, first things first. What is this thing really? Let's define our tool for the job.
Okay, in a nutshell, the GET instruction is a function that lets your PLC reach out across the network and read data from another PLC, or what we call a partner CPU. I love this analogy. Think of it like going to a library. Your PLC writes down exactly what book it wants, hands the request slip to the librarian, that's the remote CPU, and the librarian goes and fetches it and brings it right back to you. It's a request, not a command. Simple, clean, and super effective.
Now, you can't just barge into the library and start demanding books, right? There's a little bit of prep work you have to do first to make sure everything is set up for success. Here are the non-negotiables. First off, a cool feature is that the partner PLC can be in either run or stop mode. Super handy. Now listen up, because this next one is the big one, the one that trips everyone up. You absolutely must permit, put, and get access on the partner CPU. We'll look at that in a sec. Also, the data blocks you're trying to read from have to be set to standard access, not optimized. And finally, a bit of common sense. The buckets you're putting the data into has to be at least as big as the data itself. You can't pour a gallon of water into a pint glass. Okay, everyone lean in for this one. See this checkbox? Permit access with put/get communication from remote partner? This little guy, buried in the remote CPU's properties, is the source of probably 90% of all Get instruction headaches. If you forget to check this box, it's just not going to work. Period. So, pro tip, if you're having trouble, this is the very first place you should look.
All right, our workspace is prepped. Now for the fun part. Let's actually fill out that library request slip and look at what each parameter on the Get block actually does.
First up are the control parameters. Think of the requeue input as you physically handing the request slip to the librarian. A positive edge, that flicker from false to true, is what kicks the whole thing off. Then you have the ID. This is basically your library card. It tells the system exactly which PLC on the network you're trying to talk to. Next, we need the addresses. Where's the data and where's it going? ADDR1 is the book's call number. It's a pointer that says, hey, on that remote PLC, I want the data from this specific spot. And RD1? That's your mailbox. It's the pointer to the spot in your local PLC where you want that data delivered. Simple as that. And finally, the response. How do you know what happened? NDR, or New Data Ready, is your delivery notification. It'll flick on for one scan cycle to tell you, hey, your data's here. Error is, well, your damaged package alert. If that goes true, something went wrong. And the status word? That's your detailed tracking info. It gives you a specific code to tell you exactly what happened, good or bad. It's your best friend for troubleshooting.
Okay, that's enough theory. Theory is great, but let's see this thing in the wild. Let's put all those pieces together and watch it work.
So here's our setup. On the left, we've got CPU 2. Inside a data block, we've got a tag called myValue, and it's holding the number 8. On the right is our local PLC, CPU 1. It's got a tag called readValue, and right now, its value is 0. Our mission, should we choose to accept it, is to get that 8 from CPU 2 all the way over into CPU 1.
And this is the magic that makes it happen. Here is our GET instruction block, sitting right in the ladder logic. You can see we've got our start tag triggering the req input. The ID is set up for our connection. ADR_1 is pointing right at my value on the other machine, and RD_1 is pointing to our local read value tag. All the pieces are in place, ready to go.
And voila! After we trigger that start tag, we look back at our local data block in CPU 1, and what do we see? Our read value tag, which was 0 just a moment ago, is now 8. The data has been pulled across the network perfectly. See?
When it's set up right, it's just that easy.
Okay, so that was the happy path. Everything worked perfectly. But we all know that in the real world, on the plant floor, things don't always go so smoothly. So you need to know how to check if it worked, and more importantly, how to figure out what went wrong when it didn't.
This is what you want to see. This is a picture of success. The error bit is false, and the status word is a nice, clean 0. When you see this, you can trust the data you just received. It's your green light saying the job is done and everything went off without a hitch. But what happens when that error bit lights up? What do you do when things don't go according to plan?
This is where that status word becomes invaluable. It's your decoder ring for diagnostics. For example, if you see a status of 1, it's probably a physical connection issue. Check the cable. If you see a 4, maybe your data types don't match up. And if you see a status of 8, well, there's a very, very good chance you forgot to check that permit put/get access box we talked about. This little code will save you hours of guesswork.
So, let's wrap this up with the key takeaways. First, the GET instruction is a seriously powerful and straightforward tool for reading data. Second, setup is everything. If you remember one thing, remember to check that permit put/get access box on the remote PLC. And finally, don't be afraid of errors. Use the error and status outputs. They're not just warnings. They are your roadmap to fixing the problem.
So there you have it, the GET instruction, demystified from start to finish. And that really brings us to the big question, doesn't it? Now that you know how to unlock data from pretty much any machine on your network, what incredible new automations, what smarter processes, what amazing things are you going to build with it?